Using the first and second derivative tests, find all relative minima and maxima of the function f of x equal to sine x on the interval from 0 to 2 pi. First derivative test. So what does this say? This says if I have a critical point, that's where the derivative is equal to 0 or where it's undefined. We're going to check the first derivative on each side of the critical point. Okay? If there's a change of sign going from positive to negative in the derivative, then I'm going to be looking at a relative maximum. The change of sign goes from negative to positive, we're going to have a relative minimum. And if the sign stays the same, we're going to have neither. So let's take a look at what happens with sine. So we take the derivative of sine. It's going to be cosine. We set that equal to 0. So that way we can find critical points. Where's the cosine equal to 0? Cosine is going to be the x value in the unit circle. So the x value is going to be 0 at the angles pi halves and 3 pi halves. So what are we going to do next? I'm going to use pi halves and 3 pi halves to carve up my region 0 to 2 pi. So that'll look like this. And now I need to check a point in each region to find the sine of each region with respect to the first derivative. So good points to check are going to be pi fourths, 3 by fourths, and 7 pi fourths. That'll get me 1 point in each of these regions. Now, if I put pi fourths in, pi fourths goes into cosine. That's going to be square root of 2 over 2. That's positive. For 3 pi fourths, that's going to be right here. So there, the x value is negative. So that's going to give me a negative value. We don't need to worry about the actual number. We're mostly concerned with the sign. So that's going to be a negative. And then we know we're going from positive to negative. So that means I'm looking at a relative maximum. If I look at the graph, there's my relative maximum above pi halves. Okay, 7 pi fourths. We put that into the derivative. 7 pi fourths is over here. So that's going to have a positive cosine. So as I go from this region to this region, we're going from negative to positive. So I'm going to have a relative minimum there. When I look at 3 pi halves, we see there's our relative minimum. Okay, that's first derivative test. What about the second derivative test? So here, we found our critical points already. So second derivative test is going to tell us we check the sign of the second derivative at our critical point. If the second derivative is positive, okay, that's going to be a local minimum. Okay, think about it. If it's positive, it's concave up, so you'll have a minimum. If the second derivative at our critical point is negative, then we're going to have a relative maximum. Okay, we're concave down, so you'll have a maximum. If the second derivative is 0 or undefined, inconclusive, you'll have to find another way to get your answer. So let's see what happens. We take our second derivative. Derivative of cosine is minus sine. So if I check pi halves, sine of pi halves is equal to 1. So we get a minus 1. So that's going to mean we have a negative second derivative. So what's happening? It's concave down. So I have a relative max at pi halves. And we see that reproduces the result we got from the first derivative test. If we check 3 pi halves, we're going to get a 1. So in this case, we're looking at a relative minimum. Okay, we're concave up there. And then when I check the graph at 3 pi halves, again, we see that we get agreement with the first derivative test.